Hello everyone, this is another video on OSPF. In the last video, I discussed with you the functions and the features of OSPF. Now in this one, we will be discussing about the configuration of OSPF and how to configure OSPF. Let's get started. So for this lab, we'll be taking 3 routers. Let's take 2811. So these are the 3 routers I'm taking. So first of all, I'll be doing 2 labs for OSPF. One will be single area OSPF, another will be multi-area OSPF. So I'm taking 3 routers here for single area OSPF, and on the same screen, I'll be doing the another, that is multi-area OSPF. Let's connect these devices now. Okay, so in the first one, that is single area OSPF, and the second one will be multi-area OSPF. Let's start with the first topology. So this will be single area OSPF. Here we use IPs like 12.12.12.0/24 will be the network. Here we will be using 23.23.23.0/24 network. Okay, so the IPs will be like according to the router numbers. So suppose this is router 1, router 2, and router 3. So router 1 will have interface IP 12.12.12.1. Router 2 interface IPs will be 12.12.12.2 and 23.23.23.2. And router 3 will have 23.23.23.3. So these are the IPs we are going to configure. Now, before configuring OSPF, there are a few things we have to know. That in OSPF, first of all, we configure a process ID. When we configure OSPF or enable OSPF, process ID is used to configure. Then another thing is when we advertise the networks in OSPF, as I said, there is a concept of areas in OSPF. In the last video, we discussed about the concept of areas. So an area ID is used in OSPF. The range for area ID is 0 to 65535. So we divide the OSPF network into areas with area IDs from the range 0 to 65535, where area 0 is the backbone area, which is a must in multi-area OSPF. But here we are using a single area OSPF where we can use any area ID, which is called a standalone area or single area. So when we advertise the networks in OSPF, we have to assign an area ID, and we have to also use the area ID to advertise the network along with the network ID. And the network ID is also advertised along with a wildcard mask. Now, what is wildcard mask? Wildcard mask is the reverse of subnet mask, or it's also called inverse mask. So suppose your subnet mask is 255.255.255.0. That means your wildcard mask will be 0.0.0.255 or inverse. So to find out the wildcard mask, there's a formula, that is subtract the global subnet mask 255.255.255.255, and from this subtract your customized subnet mask, for example 255.255.255.0. This will give you the wildcard mask. I will explain this in some other video about just the wildcard mask. So these are a few things you have to know before configuring OSPF. That process ID is used to enable OSPF. Then area ID is used in the network command to advertise the network, and wildcard mask is used. Now let's get started. We'll start with this router, CLI command line interface, and let's configure the IPs first. You go configure terminal interface, fast Ethernet 0x0. Here the IP address is 12.12.12.1, 255.255.255.0, as it is that one before, no shutdown. Exit. Now let's configure OSPF. The command is router OSPF. Then we use a process ID. Let's say I'm using the process ID 10. The range of process IDs is 1 to 65535. Now the next is the network command. In the network command, we have to use the statement network and then network ID, that is 12.12.12.0. Then the wildcard mask. Wildcard mask, as I just discussed with you, is the inverse mask or reverse of subnet mask. So it will be 0.0.0.255, then area and area ID. Now let's suppose we are using the single area OSPF with area ID 0. So all the networks will be in area 0. That is a single area OSPF. Okay. So this router is configured. Now let's just exit and save the configurations. Like copy running config, startup config. Second router. Okay. Interface fast Ethernet 0x0, which is connected to router 1. The IP address is 12.12.12.2, 255.255.255.0. No shutdown. Then let's exit and go to another interface, that is interface fast Ethernet 0x1 connected to router 3. The IP address here is 23.23.23.2, 255.255.255.0. No shutdown. Interfaces are configured. Now let's configure OSPF. Router OSPF. Let's use the same process ID 10. Now for process ID does not need to match between the routers, as process ID is local to the router. But we are using the same process ID here. Now let's use the network. Here, now this router has two networks. One interface is in the network 12.12.12.0, whereas the other interface is in another network 23.23.23.0. So we will have to advertise both the networks. So 12.12.12.0. The syntax is network ID, then the wildcard mask, and then the area ID, area 0. Same way, we have to advertise another network 23.23.23.0. 0.0.0.255, area 0. Okay, so OSPF is configured here also. Copy running config, startup config. Last router, router 3. Interface fast Ethernet 0x0. IP address 23.23.255.255.255.0. No shutdown. Set router OSPF 10. Network 23.23.23.0. Wildcard mask 0.0.0.255, area 0. OSPF is configured here also. Let's save, copy running config, start config. Done. Okay, so our OSPF is configured. Now we have to verify. So first of all, we will verify the routing table. Show IP root. So here you should see connected root and OSPF. So here we can see one connected root, that is 12.12.12.0, directly connected on fast Ethernet 0x0, and there is an OSPF network with code O. So O is the code for OSPF. Okay. and the network is 23.23.23.0 and the administrative distance 110. We can also see by show IP OSPF neighbors the directly connected neighbors of OSPF. This is the neighbor. Now let's ping. Let's ping the router 23.23.23.3 and we can ping. So now due to OSPF, we can ping from router 1 to router 3. Okay, so this is how single area OSPF is configured. Okay, so this was single area OSPF. Next, we will configure multi-area OSPF in the second topology. So in this topology, let's take the IPs like this 12.12.12.0/25. 23.23.23.0/24 and this network that is 34.34.34.0/25. So for /25, the wildcard mask will be 0.0.0.127 according to the formula, that is 255.255.255.255 minus the subnet mask, that is 255.255.255.128. So if you subtract that, you will get the wildcard mask 0.0.0.127. So that we will use here to advertise the network. Let's get started. First router. Let me drag the window aside so that you can see. Okay, so here interface past Ethernet 0/0, IP address 12.12.12.1, 255.255.255.128 as it is /25. No shutdown, etc. Let's first configure the IPs only on this network. Interface past Ethernet 0/0, IP address will be 12.12.12.255.255.255.128. No shutdown. Another interface past Ethernet 0/1, IP address will be 23.23.23.2, 255.255.255.0. No shutdown. Okay, IPs are configured on this one also. Third router. Interface past Ethernet 0/0, IP address 23.23.23.3, 255.255.255.0. No shutdown. Interface past Ethernet 0/1, IP address 34.34.3, 255.255.255.128 again, /25. No shutdown. Now the last router for the IPs. Interface past Ethernet 0/0, IP address 34.34.34.4, 255.255.255.0. No shutdown. Now IPs are configured. Okay, so IPs are configured on all the routers. Let's just check again. So this router has IP 12.12.12.1/25. This one is 12.12.12.2/25 and 23.23.23.2/24. This is 23.23.23.3/24, 34.34.34.3/25 and 34. 34.4/24. Okay, that is a mistake. Let's change it to /25. Okay, yeah. So we have to go to configuration mode, interface, fast Ethernet 0x0, and IP address is 34.34.34/25. That means 255.255.255.128. Okay, shutdown is done, but let's just okay. So here IPs are configured now correctly. Now we have to divide it into multiple areas as it is multi-area OSPF. So let's assume this is area 0 and the other are another areas, let's say area 1 and area 2. So this one is area 0. So as there is a condition in multi-area OSPF that all the non-zero areas must be connected to area 0. So we have designed this in this way that this is area 0 and this one is area 2 and this is area 1. Now let's configure OSPF. So we'll start with this router. Okay, we are in the configuration mode. Router OSPF, let's say the process ID we are using is 1. Network, like we did in the single area OSPF, we are doing the same way here. You just have to be careful with the area IDs also. So network 12.12.12.0, wildcard mask is 0.0.0.127 as it is /25. Then area is 1. This network 12.12.12.0 is in area 1. So area 1. Okay. So this router is configured. Now let's go to second router and configure OSPF. Router OSPF 1 network 12.12.12.0 0.0.0.255 area 1. Another network is 23.23.23.0 wildcard masses 0.0.0.255 area 0. That's it. Third router. On the third router, we will be configuring OSPF this way. Router OSPF 1 network 23.23.23.0 0.0.0.255 area 0 and network 34.34.34.0 area 2. Now the last router is left. On this one, router OSPF 1 network 34.34.34.0 0.0.0.127 area 2. Okay, so OSPF is configured. Now let's first check on router 1. Show IP route. So here you can see connected and OSPF inter-area routes. If OSPF is configured fine, then we should be able to ping the last, that is 34.34.34.4. Okay, so we cannot ping, maybe we have missed some command. Let's check. So on this router, the configuration is 12.12.12.1/25 and router OSPF 1 network is area 1. Fine. This router, okay, maybe it's just taking time. 12.12.12.2/25. Okay, both the networks are advertised directly. Okay, just show the message now. Both the networks are advertised as well. Let's ping again, and we can ping. Okay, so we just verified the configuration, but it was just taking time to converge. So OSPF is correctly configured, and we can ping. So these were the configurations of OSPF for single area and multi-area OSPF. Thank you so much for watching.